Hi, welcome to Lesson 18b on Antidifferentiation. So we learned how to differentiate in the first part of the course. We did first principles and we found rates of change. We used the preceding and following intervals to do so, and then took an average to find the estimate of the instantaneous rate of change of the curve. And then we started doing differentiation, which was the actual rate of change of the curve at any point. Now we're going to do anti-differentiation, which is going to be the exact opposite of what we did before. Now, in lesson 18a, we were looking at the area under the curve, and as it turns out, the area under the curve is the definition of the integral. So the first principles of the integral is to find the area under the curve. Okay, so we've done that. And so if we were to find some function y when given dy by dx, that would be finding the antiderivative of this derivative. And if we find f of x from f prime of x, it's the same thing. It's the reverse process of differentiation, which is antidifferentiation. Okay, so just as this graphic shows us right there. Okay, so just have a little quick read through that. So the antiderivative is basically finding what the original function would have been if you've been given the derivative to start with. So you get the derivative, you work backwards to find the antiderivative, or the original function. Okay, so if this capital F is the antiderivative of f, then the derivative of this capital F is actually just the given function itself. So suppose we have fx equals x cubed. If we want to find the antiderivative of it, well, because when we take the derivative we subtract 1 from the exponent, the antiderivative would be adding 1 to the exponent. So we're going to first start with x to the power 4, and we'll take the derivative of that. Okay, so then now we've got the same matching power of x cubed. So what we need to do is, what would we do to this to end up getting just the 1 in front? So if we started with x to the power 4, we take the derivative, so the 4 drops down in front. But if we just want a 1 in front, what do we do to the 4 mathematically to just get a 1 here? Okay, but because we know that we multiply this exponent down in front, then that would mean we have to multiply by something. Have to multiply this 4 by something to get 1. So then the antiderivative, capital F of x, is 1/4 x to the power 4. So if you check that by differentiating, you take the 4 down in front, 4 times 1/4 is 1, and then that leaves you with x cubed. Okay, so that would be the antiderivative. Okay, so what about this one? A little bit trickier, but we've got just 2 terms now. It's the same sort of idea as this. This first example, just with 2 terms. We want to find the antiderivative of 6x cubed minus 8x. Well, if this is the derivative, we know that 1 has been subtracted from the exponent in both of these. So we're going to start with x to the power 4 and x squared, which is 1 power higher than these 2 powers. Okay, so if we take the derivative, d by dx, of x to the power 4 minus x squared, then we drop that down, we get 4x cubed minus 2x. So now what we want to do is we want to know, well, what do you multiply 4 by to get 6? Okay, so we're starting off with x to the power 4, because that's 1 power higher than x cubed. and we've got x squared, because that's 1 power higher than x. So what do you multiply 4 by to get 6? Well, if I were to divide this by 2, for example, I'd get 2, and then I multiply that by 3, you get 6. So it'd be 3 over 2, x to the power 4. And what do I multiply negative 2 by to get negative 8? And we've got negative 4 there. So just to check this, we take the derivative, so we take 4, bring this down in front. 4 times 3 over 2, well 4 times 3 is 12, divided by 2 gives us 6. And then that derivative, that exponent drops down to 3. And then for this term here, we bring the 2 down in front. Negative 4 times 2 gives us negative 8. We subtract 1 from the exponent here just to get x. Okay, so that is the antiderivative.